Separating metals from metal oxides is a fundamental process in metallurgy, essential for obtaining pure metals from their natural sources. Many metals are found in the Earth's crust not as pure elements, but as part of compounds, particularly metal oxides. These metal oxides are formed when metals react with oxygen over geological timescales, either in the Earth's crust or through the weathering of ores. To obtain the pure metal, the metal oxide must be reduced, meaning the oxygen must be removed, leaving behind the elemental metal. The process of separating metals from their oxides typically involves chemical reactions that reduce the metal oxide back to its metal form. This reduction process is essential because most metals are more stable in their oxidized form, so energy must be input to break the bonds between the metal and the oxygen. The method used to reduce a metal oxide depends on the reactivity of the metal. Metals that are lower in the reactivity series, such as iron, lead, and copper, can be extracted from their oxides using carbon in a process known as reduction with carbon. Reduction with carbon is a cost-effective and efficient method for extracting metals from their oxides. In this process, the metal oxide is heated with carbon, typically in the form of coke or charcoal. During this reaction, the carbon acts as a reducing agent, combining with the oxygen from the metal oxide to form carbon dioxide CO2, while the metal is left behind in its pure form. For example, the extraction of iron from its oxide, iron, oxide Fe2O3, occurs in a blast furnace where the iron ore is heated with carbon. The reaction can be represented as shown on the screen. In this reaction, the carbon reduces the iron oxide to iron, with carbon monoxide CO also being produced as a byproduct. This process is used extensively in the steel industry, where iron extracted from its ore is then further processed into steel. However, not all metals can be extracted using carbon. The effectiveness of carbon as a reducing agent is limited to metals that are less reactive than carbon itself. Metals higher in the reactivity series, such as aluminum, are too reactive to be reduced by carbon. These metals have a stronger affinity for oxygen, making it difficult for carbon to remove the oxygen from the metal oxide. Therefore, more energy-intensive methods, such as electrolysis, are required to extract these metals. The need to separate metals from their oxides is driven by the widespread occurrence of metal ores in oxidized form and the demand for pure metals for industrial, technological, and economic purposes. The method of reduction with carbon is particularly significant because it allows for the extraction of metals like iron, which are crucial for construction, manufacturing, and many other industries. This process underscores the importance of understanding both the chemical reactivity of metals and the practical methods available for their extraction.